solve for the indicated value and then graph the situation showing the solution point. The formula for measuring sound intensity in decimals is defined by D equals 10 times the log of the intensity divided by the initial intensity. And then they go on to tell you, using the common base 10 logarithm, where I is the intensity of the sound in watts per square meter. So that's right here. And I sub 0 equals 10 to the negative 12. So that's right there. Is the level of sound that the average person can hear. How many decibels are emitted from a jet plane with a sound? Oh my gosh. With a sound intensity of 8.6 times 10 to the second. So this is going to equal 10 times the log of, and then my numerator is going to be 8.6 times 10 to the second. And my denominator is going to be 10 to the negative 12. And if you've got your calculator, you should be able to type all of that in there, but because it says round your answer to 3 decimal places, but I kind of like to simplify things because sometimes typing it into my calculator is difficult. I've got 10 to the negative 2 over 10 to the negative 12. If you have the same base and you're dividing, you can subtract the exponents. So this will be 10 to the 2 minus the negative 12, which is 10 to the 2 plus 12, which makes this 10 to the 14th. So this is going to be 10 times the log of an 8.6 times 10 to the 14th. And that's a little bit more manageable on my calculator. So I'm going to do that. 10 times log parenthesis 8.6 times 10 and raise that to the 14th power. Make sure you scroll over before you close the parentheses and hit enter. And what I get is 149.344985. And what do they want me to do? It says round your answer to, I meant to change that to a different color. Round your answer to 3 decimal places, and your third decimal place, this would be 1, 2, 3 decimal places, but the next number is a 9. So this is going to go up to 149.345. All right, 149.345. 149.345. And then it says select the correct graph. Remember that our, let me go back. What was it? Okay, when I look at the graphs, I need to see how they're labeled, and they are not labeled. Okay. All right, well, keep in mind that these are not labeled. What the hell? Okay, well, that is so weird. Oh, I'm going to guess that I take it back. Now that I'm looking at it, they are labeled. There's an I right there. That's weird. Usually put it off to the side, but I see it there. So my x-axis is intensity, and then there's a D, so my y-axis is my decibels. And so I'm looking for a point that has a y coordinate of 149.345. And then I was an 8.6 times 10 to the second. 8.6 times 10 to the second. That's your I, right? I. And that would be 8.6 times 10 to the second is 100. So we're looking at 860. We are looking at an ordered pair that has the x coordinate or the I coordinate of 860, and then the D coordinate, that is this. That's the 149.345. So I'm going to go over to the x-axis at 860, which would be, if that's 800 and that's 1200, that's 1,000. So halfway would be 900, so 860. But that only goes up to like 30, so it can't be the bottom one. And these look like they have the same x-coordinate. That's not 140. This is 100 and that's 150, so 100, 110, 120, 130, 140, 150, and we are looking at 149, so almost 150. That's not high enough to be 150. That one would work. That looks pretty damn close. Or is that right on 150? That one's too low, and this one's too far to the left. Yep, it's got to be this one. This point right here looks like it is above 860 and to the left of the 149, so it's got to be that one. So now let's go up. How did I do? I got green squares everywhere. Woohoo!